Happy morning, all of you. Now we are discussing P block element 1, lesson number 2. The last class we discussed about structure of diborane and about the uses of diborane. One more important topic we learned that one, boron trifluoride and their reactions and uses. And now we are going to discuss about the preparation of aluminium chloride. Two preparation they are having and two properties and uses, and one more important topic is about the alum, preparation of alum, that is about the potash alum. Very important question. Potash alum means K2SO4 Al2SO4 thrice 24H2O. These are the important topics we are going to learn, and about the very important question is about that uses of potash alum. Okay, we can be discussed one by one. Please all of you take the note. Today we can be discuss about that preparation of aluminium chloride, properties of aluminium chloride and uses of aluminium chloride. Okay, preparation of aluminium chloride, properties of aluminium chloride and uses of aluminium chloride. And one more important terms we can be discussed, that what are alums. Okay, what are alums and their reactions and uses of alum. Okay, this can be written, this can be learned today. So it's a very important for the preparation of alum. Okay, aluminium chloride also one of the reactions, also very important. Please learn it. First one, aluminium chloride. Aluminium, what is the formula for aluminium chloride? AlCl3, aluminium chloride. How it is prepared? Aluminium metal on reacts with hydrochloric acid, we get aluminium chloride. Okay, this is the one method. Second method, aluminium hydroxide undergoes reacts with hydrochloric acid, we get aluminium chloride and water. Okay, these are the two steps we have. First one, aluminium metal, that is aluminium Al, reacts with hydrochloric acid, we get AlCl3 and also we get hydrogen. Okay, you have to write the equation. Aluminium plus HCl gives AlCl3 plus H2. How can you balance the equation? First you have the product side, make it 2. 2 into 3 is equal to 6. Am I right? So here make it, the reactant side, make it 6 hydrochloric acid. How much aluminum is there? 2 aluminum. Now count the hydrogen. How much hydrogen is there? 6 hydrogen. Make it 3 here. Now the equation is balanced. Second, about aluminium hydroxide on reacts with hydrochloric acid. What is the formula of aluminium hydroxide? AlOH thrice. This on reacts with HCl, we get AlCl3 plus H2O. AlCl3 plus H2O. Okay. Now, how much chlorine is there? In the product side, 3 chlorine. So make it 3 here in the reactant side. So chlorine balance. Here 3 hydrogen, 3 OH. We can written as 3 H2O. Now the equation is balanced. Next is about that McPhee process. McPhee process. That is also the preparation of aluminium chloride. Aluminium chloride, that is aluminium trioxide. Aluminium trioxide. What is the formula for aluminium trioxide? Al2O3 on reacts with carbon and also we are using chlorine, we get AlCl3, aluminum chloride, and carbon dioxide, and we get the carbon dioxide gas. Here, what are the reaction is going on? Carbon combines with oxygen. Carbon combines with oxygen, we get carbon dioxide. Am I right? So the aluminum is easily reacts, combines with chlorine, we get aluminum chloride. How can you balance the equation? Here, how much oxygen is there in the reactant side? 3 oxygen. Am I right? So if you are making 3 oxygen in the product side, means 3 carbon dioxide, 3 CO2, and the carbon also make it 3 here. Now that is balanced. Okay. Next, what about here oxygen? 3 into 2 is equal to 6. Am I right? 3 into 2 is equal to 6 here, the product side. So here also make it 2 in the reactant side, 2 aluminum. So aluminum, how much is aluminum there? 2 into 2 is equal to 4. So make it 4 here. Now the equation is balanced. Another one reaction, aluminum metal on react with chlorine, that we are saying chlorinating of aluminum. Okay, that aluminum reacts with the chlorine. The temperature is about 1000 degree Kelvin, 1000 Kelvin. We get aluminum chloride. Aluminum chloride. Aluminum on reacts with the chlorine, we get aluminum chloride. Okay. So we have to balance the equation. How much chlorine is there? 3 chlorine, the product set. So make it 2 here. Okay, 2 into 3 is equal to 6. Also here also make it 3 into 2 is equal to 6 and 2 aluminum is there. Now the equation is balanced. Next about what are the properties of aluminum chloride? First one, aluminum chloride is a colorless. Okay, aluminum chloride is a colorless and also hygroscopic substance. Am I right? Second one, in aqueous solution, aluminum chloride is an acidic in nature. Important point, please underline that one. In aqueous solution, aluminum chloride is an acidic in nature. It also produces hydrogen chloride fumes in moist air. For example, aluminum chloride, that is formula is AlCl3, reacts with water, H2O, we get aluminum hydroxide. That means hydrogen combines with the chlorine, we get HCl. What's remaining? AlOH thrice plus HCl. How much chlorine is there? 3 chlorine. So product said 3 chlorine. How much hydrogen is there? 3 hydrogen. So make it 3 water molecules. Now the equation is balanced. Am I right? With ammonium hydroxide, it forms an aluminium hydroxide. Aluminum chloride on reacts with ammonium hydroxide. What is the formula for ammonium hydroxide? NH4OH. Am I right? NH4OH. Ammonium hydroxide. Ammonium. That is AlCl3, aluminum chloride, on reacts with ammonium hydroxide, that is NH4OH. We get aluminum combines with the OH to form aluminum hydroxide, AlOH thrice, plus ammonium combines with the chlorine to form NH4Cl. How much chlorine is there? 3 chlorine. So how much ammonia is there? 3 ammonia. Am I right? Next, it is balanced. Am I right? Next, aluminum chloride, AlCl3, on reacts with the sodium hydroxide, NaOH gives, we get aluminum combines with sodium and oxygen, we get NaAlO2, sodium meta-aluminate. Okay, what is the product is obtained? Sodium meta-aluminate. What is the formula? NaAlO2. And sodium combines with the chlorine to form NaCl. And the hydrogen combines the OH to form water molecules, H2O. How can we balance the equation? How much chlorine is there in the reactant side? 3 chlorine. So the product side 3 NaCl. Make it 3 chlorine. So 3 NaCl. So here having 3 Na and one more sodium is there. So 4 Na, right? So the reactant side make it 4. Okay. Next, what about the hydrogen? Hydrogen here having 4. So make it 2 molecules of water. Now the equation is balanced. Okay. Next about that. What are the uses of aluminium chloride? What are the uses? One is about that. Aluminium chloride is used as a catalyst in Friedel-Crafts reaction. Catalyst, all of you know, what is about the catalyst? It is a substance which alters the rate of the reaction. Alter means changing the rate of the reaction. Whether it may be speed up the reaction or slow up the reaction. That we are saying catalyst, I'm right. Next about, it is used in the manufacture of petrol by cracking the mineral oils. The third use is, it is used as the catalyst in the manufacture of dyes, drugs and perfumes. Next, our portion is about that. Alum, okay? Alum. This is just like a white stone, am I right? The alum has some uses, okay, for purifying water, for a small bleeding in our body. It should be arrest the bleeding like that. And also it is very important use for waterproofing and textile. Am I right? It's very, very important uses for the alums. Main purpose is we are using for the purification of water and it arrests the bleeding. Okay, one of the very important. Some of the uses also having it is used in the dyeing, paper and leather tanning industries. Some of the industries are also using alum. Okay. So anyhow, before that we have to learn about alums. The name alum is given to the double salt of potassium sulfate and aluminum sulfate with water molecules. Double salt. What's the meaning of double salt? A compound having two different types of salt. A compound having two different salt. That we are saying double salt. Am I right? For example, first one, I'm taking one of the examples, potassium sulfate, K2SO4. Aluminium sulfate, Al2SO4, thrice 24 molecules of water. This is called what? One of an alum. Okay, one of an alum. We are saying potassium. Okay. So, here, nowadays, it is used for all double salt with M single dash, SO4, that is M2SO4 single dash, M double dash to SO4, thrice 24 H2O. What is about this M single dash? M means metal. Okay. For example, sodium metal. This M single dash means it is one of the univalent metal. Univalent means single type of metal. For example, Na plus, potassium plus, K plus, NH4 plus. These are all what? Univalent metal ion. What is M double dash? That M double dash means a trivalent metal ion. Trivalent metal ion means Al3 plus. Am I right? Aluminium 3 plus. Chromium 3 plus. For example, aluminium 3 plus means what is the atomic number of aluminium? Aluminium is 13. Am I right? In first shell we can be accommodate 2 electrons. Second shell we can be accommodate 8 electrons. So 2 plus 8, 10. What's the remaining? 3 plus. The aluminium can lose 3 electrons. Am I right? So 3 plus. Chromium, it also can lose 3 electrons. Sodium, it can be lost 1 electron. So it becomes an univalent. Potassium, atomic number is 19. Am I right? Atomic number is 19. First shell we can be accommodate 2 electrons. Second shell 8 electrons. Am I right? Third shell again 8 electrons. Fourth shell 1 electron. So it can be lose 1 electron easily. So it is an univalent. Okay. Here, what are the important Examples. What are the important examples? Potash alum, sodium alum, ammonium alum, chrome alum. These are all some examples of alum. First about the potash alum. We can discuss the potash alum. We have to learn the formula. Okay, this is one of the one-word question, important question, one-word question. Okay, try to learn the one-word question. Potash alum, what is the formula? K2SO4 dot Al2SO4 thrice 24H2O. Next, sodium alum. Sodium alum. For example, here we are using potassium. Am I right? So potash element we are using. Suppose you replace by sodium means we get sodium alum. So how will you write sodium alum? Na2SO4 dot Al2SO4 thrice dot 24H2. This is about the sodium alum. Next we are taking ammonium alum means the sodium is replaced. We are replacing by adding ammonium. So what is the formula? NH4 twice SO4 dot Al2SO4 thrice 24H2O. Okay, next about the chrome alum. Chrome alum means we are taking potassium sulfate and Cr2SO4 thrice 24H2O. Okay, so what are the alum here? Example 4 alum, potash alum, sodium alum, ammonium alum and chrome alum. Okay. Then what are the preparation of potash alum? One of the very important question, very important question. Potash alum. How is potash alum prepared? Okay. Potash alum is prepared from alunite. That we are saying one of an alum stone. Okay, one of an alum stone. Okay, it is a naturally occurring form. Okay, it is about what is the formula? Alunite. Alunite. Otherwise, we can be say alum stone. What is the formula of alunite or alum stone? What is the formula means? K2SO4 Al2SO4 thrice 4AlOH thrice. This is the alum stone formula, otherwise alunite formula. What is the formula? Al2SO4 thrice, K2SO4, 4AlOH thrice. Here, when alum stone is treated with excess of sulfuric acid, the aluminium hydroxide part, listen all of you, this example having aluminium hydroxide. This aluminium hydroxide part is converted into aluminium sulfate. Can you understand? The AlOH thrice, this part is converted into aluminium sulfate. Here, a calculated quantity of potassium sulfate is added to the crystal. Okay, here adding a small calculated quantity of potassium sulfate is added to the solution, is crystallized, okay, to generate potash alum. Can you understand, my dear children? So, what is the concept here means? We have to learn about the alunite, otherwise alum stone. What is the alum stone formula? K2SO4 Al2SO4 thrice 4AlOH thrice. Here the alum stone is treated with the excess of sulfuric acid. We are treating with the excess of sulfuric acid. Here the aluminium hydroxide is, that aluminium hydroxide part is converted into aluminium sulfate. That is AlOH thrice part is converted into Al2SO4 thrice. A calculated quantity of potassium sulfate we are adding. Okay, we are adding. Then the solution is crystallized to get potash alum. Okay. Now we can write the formula of that alum stone. Okay, otherwise alunite. What is the formula? What's the formula means? K2SO4 Al2SO4 thrice 4AlOH thrice. What is the name of this compound? Alum stone or alunite. This on treatment with the calculated quantity. We are adding some more some sulfuric acid, constant sulfuric acid. We are adding some sulfuric acid. What's the formula? H2SO4. So what is happening here? We get this aluminum hydroxide part is changed. This part is changed into aluminum sulfate. That is 4AlOH thrice part is changed into aluminum sulfate. So what are the possibility we get? K2SO4 plus AlSO4 thrice. Am I right? AlSO4 thrice plus water molecules. How much water molecules? 12H2O. 12H2O. Here, how can you solve this one? How can you solve this one means, in the reactant side, they are having 2 aluminum plus 4 aluminum. Total we get 6 aluminum. Am I right? If you are adding 3 means the equation is solved. Am I right? Al2SO4 thrice. Equation is solved. Okay. Next about the hydrogen is also 12 means 4 3s are 12. So we are right. We can be easily write 12 water molecules. That is 4 into 3 is equal to 12. We know that one. How to write? 12 means half you have to write. Am I right? For water. Next. Second step. Here we get the product. Which are the product is obtained? K2SO4 plus Al2SO4 thrice plus 24H2O. 24H2O means, how it is changed means, we know that the potash alum. What is the potash alum formula? K2SO4 Al2SO4 thrice 24H2O. Already we learn, am I right? What is the formula for potash alum? K2SO4 Al2SO4 thrice and also 24H2O. So we are writing like that, such a way like that. K2SO4 plus Al2SO4 thrice plus 24H2O. We get K2SO4 plus Al2SO4 thrice plus here the product you have to write K2SO4 dot Al2SO4 thrice dot 24H2O. This is what? Potash alum. Potash alum. Can you understand? The reactant side they mention like that plus. The product side we have to mention like that dot. Okay. Potash alum dot potassium sulfate dot aluminum sulfate dot 24H2O. That is a formula for what? Alum. Next about, what are the properties of potash alum? What are the properties? It is a white crystalline solid. So what is the first property? It is a white crystalline solid. It is soluble in water and insoluble in alcohol. Can you understand? It is a white crystalline solid. It is soluble. This potash alum is easily soluble in water, but it is insoluble in alcohol. Am I right? The aqueous solution is acidic. What's the reason means? Due to the hydrolysis of aluminium sulfate. Okay? It melts at, what's the temperature? It's a one word for the temperature, melting point. Okay? 365 Kelvin. Okay? At 475 Kelvin, it loses the water of hydration and swells up. Okay? What's the temperature? At 475, what is the temperature? At 475 Kelvin, it loses water of hydration and swells up. The swollen mass is known as burnt alum. Burnt. Okay, the swollen mass is called what? Burnt alum. Then heating to the red hot. When we are heating this alum on heating it red hot, it decomposes into potassium sulfate, alumina, and also sulfur dioxide. Okay, so these two equations you have to write. Okay, one is about that. First one, it loses the water. Am I right? That is, we are saying dehydration. We are saying hydration. Removal of water molecule. Okay, hydration, removing. So what is the equation? First we have to write potassium formula. What is the formula for potassium? K2SO4 Al2SO4 thrice dot 24H2O on heating at 500 Kelvin. We get K2SO4 dot Al2SO4 thrice plus water is removing 24H2O. Water is removing from the reactant side. Water is removing. This is the first action. What's about the temperature? 500 Kelvin. Second, K2SO4 dot Al2SO4 thrice. K2SO4 dot Al2SO4 thrice during the red hot heat we get K2SO4 plus, we get alumina. What is the formula of alumina? Al2O3 and plus sulfur trioxide. What is the formula? SO3. How much sulfur is there? 3 sulfur here. So make it 3. Okay. Then potassium forms aluminium hydroxide when treated with ammonium hydroxide. Potassium on treatment with ammonium hydroxide. What is the formula? Ammonium hydroxide NH4OH. NH4OH. We get what? Aluminium hydroxide. Don't forget that aluminium hydroxide. Okay. First you have to write potassium formula. What is the potassium formula? K2SO4 Al2SO4 thrice 24H2O on reacts with ammonia hydroxide. What's the formula? NH4OH. So what are the possibilities here? Potassium sulfate. What is the formula? K2SO4 plus. Here the aluminium combines with OH of ammonia. We get aluminium hydroxide. And also this ammonia combines with the sulfate to form ammonium sulfate. What is the formula for ammonium sulfate? NH4 twice SO4. NH4 twice SO4 plus 24H2O, including aluminium hydroxide plus AlOH thrice. So how much aluminium in the reactant side? 2 aluminium. So make it 2 aluminium the product side. How much water molecules? 24. That is the correct only. 24H2O. Next about ammonium sulfate. Ammonium. Here ammonium sulfate. What's the formula of ammonium sulfate? Ammonium NH4 twice SO4. So make it 3 here. 3 here. So sulfate is 3. So there also sulfate is 3. Am I right? Equation is balanced. Am I right? 3 ammonia. Make it 3 ammonia. 3 ammonia is make there. For 3 ammonia, why we are using 3 ammonia? 3 into 2 is equal to 6. So make it the product side. 3 into 2 is equal to 6. We are making it 6. Am I right? Then what are the uses of alum? Previous I told you that what are the uses of alum? Purifications of water. Second one, waterproofing and textile. It is also used in waterproofing, means we are saying that on a raincoat. During the rainy season we are wearing the raincoat, am I right? So that is about that waterproofing and textile, and it is used in dyeing, paper and leather tanning industries, am I right? Dyeing, paper and leather tanning industries. It is employed as a septic action agent to arrest bleeding. That is about that. If our body have any wound like that, any happen means when the bleeding comes means it should be arrest. Which one? The potash alarm will be arrest the blood from bleeding. Okay. Next about that. What are the group 14 element? Group 14 element. Okay. What are the group 14 element? That means carbon, silicon, germanium, tin and lead. Am I right? Carbon, silicon, germanium, tin and lead are called as what? Group 14 element. Okay. We know that carbon is found in native form of graphite, coal, crude oil. Am I right? Some and also some carbonate rocks. Okay. Calcite, then magnesite. These are all containing what? Carbon. These are all in combined form. Am I right? Silicon, you know that on silica means sand, quartz crystals. These are all silica. That is sand. We are saying silica. Some clay. Silica is obtained from some clay also. Okay. Some of group 14 elements. Some of the physical properties. That is physical properties. What about this group 14 elements? All the elements are in solid state. We know the atomic number. Carbon atomic number 6, silicon 14, germanium 32, tin 50 and lead 82. These are all in our periodic classification, periodic table. Next about that isotopes. What are the isotopes of that is about the p block element in group 14? Carbon 3 forms. We have carbon 12 isotope, carbon 13 isotope, carbon 14 isotope. Am I right? Silicon also exists to isotopes. That means silicon 28 and silicon 30. Germanium also exists to isotopic form. One is germanium 73 and 74. Tin and lead exist single form. Am I right? Then atomic mass, electronic configuration. Already we learned thoroughly about the electronic configuration. I hope that no one have doubt about the electronic configuration. The density, melting point, boiling point, you have to learn thoroughly for the one-word question. Okay, density, melting point and boiling point. This you have to learn. One of the important term is about that catenation. What is about the catenation? Carbon, one of the ability to form a chain of atoms. That is the ability of an element to form chain of atom. For example, carbon linked with the carbon, linked with the carbon, like that. Carbon can form a long chain of atoms. That we are saying catenation. That is self-linking of an atom. Okay, self-linking. What are the conditions for the necessary catenation? Means what are the conditions? Number one condition, the valency of an element is greater than or equal to 2. That is one condition. 2 or more than 2. The valence element must have 2 electrons. Am I right? Otherwise, more than 2. Like that. Minimum, they must have 2. That's electron. Am I right? Second one, the element should have the ability to bond itself. Which are the element? That the element can ability to bond itself. Carbon can bond with carbon. Okay, bond with itself. Third one is the self bond. Explain about the self bond. That is carbon bond with carbon, carbon bond with carbon, carbon bond with carbon. Sometimes carbon bond with the oxygen, carbon bond with the nitrogen, like that maybe. So it is a self bond. The self bond must be strong. The self bond must be strong and its bond with other element. The fourth point is about that kinetic inertness of a catenated compound towards other molecule. kinetic inertness. Kinetic means it explains the rate of the reaction. The reaction may be going fast or the reaction may be going slow. Explain about the speed that we are seeing the molecular motion. Am I right? The speed of the reaction may be inertness. That means we are saying inertness means, inert means what is the meaning of inert? It's not reactive. Am I right? And the candidate compounds are towards other elements. These are the 4 points about the candidation. And about that, carbon possess the above properties. What are the 4 above properties? From a wide range of compounds with itself. They are making different compounds, making other compounds, carbon monoxide, carbon dioxide, like that many compounds with other elements such as. It can be bonded with hydrogen, oxygen, nitrogen, sulfur, and also we are using halogens. Okay, halogens. These are all about the candidation. Okay, that from the next class we can be discuss about the allotropy of carbon. Okay, that is a very important question. So we can be discuss the next class. So today our assignment is about that. First one, alum. Okay, what is about the alum? It's a preparation of alum. The first one is preparation of alum. Second one is uses of alum. First one is about the preparation of alum. Second one is uses of alum. Okay, these are the 2 assignments. Thank you all of you. Thank you. Have a nice day.